Today I'm going to show how to solve the problem of finding longest palindromic substring. Okay, so the problem is to find the longest palindromic substring. So for example, suppose you are given a string as B A B A D and you need to find the longest palindromic substring in this string. So the longest palindromic substring in this string is BAB and ABA. You can return either of them. Another string as is given CBBD and the longest palindromic substring here is BB. So if you look at the above palindromic substring, right, the first string has BAB. What is the length of that palindrome? It's 3, which is odd. Okay, so in this case the length of the palindrome is odd, and here this is even, it's 2, so in this case it's even. Now the approach that we are going to use is we are going to use this odd and even length palindrome, and then we are going to expand around the center. Okay, so the name of our approach is expand around the center. What does this approach mean? Suppose you are given the string BABAD, okay? So let's consider that we are just trying to find the odd length palindrome, okay? So in the odd length palindrome, what happened? There's one unique character in the center and then there are mirror images on both of the side. So what we'll think that this first character, this is our center, and we'll try to find the mirror image on both the sides. We have here A, but there's nothing on this side because it's going out of range. So here we found only one palindrome. The odd length palindrome that we found is B. Then we take this A and then we try to expand around the center. So we try to compare this B and B. Oh, it matches. Great. Let's move back again. There's nothing before B and there's A here, but there's nothing before B. So here the longest palindrome that we found is BAB. Right now we are just trying to find the odd length palindrome. Now we try to expand around this, considering this as a center. So we try to see, this is a center, so this has, this matches with itself. Then we go back. We decrement this and increment this, and A matches. Great. Then we are going to decrement this and increment this, but B and D, doesn't matches. So the longest palindrome that we find of odd length is ABA. Then again we try to expand around this center. Nothing, B and D, they don't match. So the longest odd length palindrome that we found is A. Again we try to expand this considering this as a center. The longest palindrome that we found is B. And out of all this, you have to return the longest one. Doesn't matter which one you return, you can either return BAB or ABA. The same thing you can also do for the even length palindrome, okay? So for example, consider the string CBBD, okay? So for the even length, you have to consider the two characters, okay? And because even length will be, let's check more like this. Let's take the example like this, okay? So you will consider the first two middle characters, okay? So we'll consider this two as the middle character. We'll see, are those two characters matching? They are not matching. So we haven't found an even length. Then we will consider this two as a middle character. We'll see, are those two characters matching? No, they are not matching. Then we'll consider this two as a middle character and we'll see, are those two characters matching? Yeah, that's matching. So we'll decrement this and increment this and we'll see, are these two characters matching, A and A? Yep, they are matching. Then we'll again decrement this and increment this, and we'll see is C and D matching? No, C and D are not matching. So the longest even length palindrome that we found so far is ABA. Then again, we consider this 2 as a middle character. They both are not matching. This 2 as a middle character. They both are not matching. So that's how you do for the even length palindrome. Let's take one more example for even length palindrome. ABBA C C D D. Okay, let's take this example. So here we'll consider this two as a middle character. They both are not matching. We'll consider this two as a middle character. They both are matching. So decrement and increment. Decrement the left pointer and increment the right pointer. They both are matching, and then there's nothing to decrement. So the max even length palindrome found so far is this. Then we consider this two as a middle character CC. They both are matching, but then when we increment the left and the right pointer, A and D are not matching. Then we consider this two as the middle character. They both are matching. Then we decrement the left and the right pointer. They both are matching CC. Then we again decrement and increment. This CC is matching. Again, we try to decrement and increment, but it goes out of boundary, out of length. So CC, DD, CC. Okay, so that's, and out of this, the max even length is this. Again, we consider there was also CC, which was even length palindrome. There was also BB, which was even length palindrome. Then there was also DT, and then so on. Okay, so this is a max even length palindrome. Okay, so now the approaches we are going to use, let's write down our approach. So what we are going to do is expand around the center. Okay, we are going to consider each index as the center of even and odd length palindrome. Even an odd length palindrome. Then we will keep expanding and record the max length palindrome found. So what is the time complexity of this approach? So we are considering each index as a center and then we are expanding, right? So it's O of n square. O of n square. What is the space complexity? No use of extra space, so O of 1. Now let's implement this. Public, we're going to return the maximum, the longest palindrome. So public string find longest palindromic substring. String S, okay? So we need to find the longest palindromic substring. So let's cover the base case. The base case is if our string S is null or S is empty, in that case there's no longest length palindrome, so just return S. Just return S in that case. And we're gonna take an integer max length to record the maximum height. And we are also going to take integer start index for the start index of our max length string, and then the index of our max length string. Now we are going to loop, okay? So for integer I is equal to 0, I less than s dot length I plus plus. So now integer, first we are going to do the odd length, okay? We are going to find if there's an odd length palindrome and what's that length, okay? So odd length, and then we're gonna find the max odd length, okay? Max odd length, and then we're gonna pass the string. For the odd length there's only one middle character, okay? So I left and right both are equal. And again we are going to do the same thing for the even length. So we're gonna find max even length palindrome. So find max even length palindrome, and for the even length palindrome we're gonna take two middle characters as the center, so I and I plus 1. Now out of this max odd length and max even length, we're gonna take max of both. I mean, we're gonna find the max of what is max between odd and even. So if odd length is greater than max length, then what we're gonna do is we're gonna update the max length. The max length will be odd length, and what will be the start index? So the middle character is the ith character. So what will be the start index? There will be equal number of character on left and right. So suppose the odd length string is 5, right? Then there's one middle character and there will be two characters on the left, two characters on the right. So to find the start index, we just need to do I minus whatever the odd length is, divide by 2. I minus odd length divide by 2. That will give you the start index, and n index is equal number of characters on the right side. So end index is I plus odd length divided by 2. So that gave you the max length string and its start and ending index. Now similarly, if even length palindrome, the length of the even length palindrome is greater than max length, then again we are going to update the max length. Then we have max length is equal to even length. Now what will be the start IDX in case of even length? So there's a I and I plus 1. Those two are the middle characters, right? So let's say if you have an even length string of length 6, right? Then there will be two middle characters, and then on the left side there'll be two more characters, and on the right side there'll be two more characters, right? So it should be I, so the start index will be I minus whatever the even length is. So even length is 6. So let's say your I is, let's say the even length string the even length palindrome is 6 characters. So let's say it's starting from 2. So 2, 3, 4, 5, and 6. These are the indexes, okay? And 7, okay? So your I is this 4. That's your I, okay? This is your I 4, and the I plus 1 is 5, right? So I is 4. And you need to find the starting index, which is 2, right? So the even length is 6. So 6 minus, so even length minus 1, that is 6 minus 1, which is 5, and divide by 2, which is 2. So I is 4. So 4 minus 2 will give you 2, okay? So that's what you have to do. And what will be the end index? So I is 4. So what will be the end index? 4 plus even length divided by 2. So the even length is 6. 6 divided by 2 is 3. So 4 plus 3. So I plus even length divided by 2. So that's the n index. And we got it. Now what you have to return is, we completed this for loop also. And what you are going to return is a string. So s dot substring, we know the start index, the string that is starting at the start index, and it's ending at this end index, right? So but we have to do +1. Why? Because the substring function exclude the character at the end index, so we have to do +1, right? And there you go. Now let's implement our helper function, public integer find max length, and we have our string as, we have integer left, low, and integer high, right? So what we are going to do, we are going to check while we have low is greater than equal to 0 and high less than s dot length. While that's the case, we are going to compare the characters. So s dot character at low is equal to s dot character at high. In that case, what we are going to do, decrement low and increment high, right? So but what happens when they are not equal? Well, in that case, you're just going to break the while loop and come out. You're done with your while loop. And when you come out of the while loop, you need to return the length of the palindromic string. So you're gonna return high minus low. So let's say when you come out, let's say you have the string A, C, B, B, C, D. So when you come out, your high is 0, 1, 2, 3, 4, 5. Your high is here, which is 5, and your low is here, which is 0. So what is the length of the palindromic string? 4. So 5 minus 0 minus 1. That gives you 4. And that's it for that function. Okay. So now with this approach, the time complexity is n square. Now the question is, is it possible to do in a linear time? And the answer is yes, you can do it in the linear time. Okay, so I'll show you what is the approach to do it in a linear time. Okay, so in order to do it for the linear time, you have to follow the suffix trie approach, which will give you the time complexity, which is linear. Okay, so in this suffix trie approach, think that you are given a string, for example, B-A-N-A-N-A, banana. Okay, you are given a string S, and you need to find the longest palindromic substring. Okay, so banana has many palindrome. Okay, if you look at it, you have A, sorry, A-N-A, then you have A-N-A, N-A, right? And then you have the individual character as a palindrome, right? So for the string, the answer should be, the output should be A-N-A-N-A. Okay, now what we are going to do, if you look at the string, okay, and when you reverse the string, okay, so it will be A-N-A-N-A-B. Okay, so that's the reverse. Now when you create a suffix trie, okay, for this S and R, okay, when you create a suffix trie for this S and R combined together, you create one suffix trie which is called a generalized suffix trie. Okay. For this approach, I would ask you to listen to my previous video of the pattern searching using the suffix trie, because you need to have the knowledge of what the suffix trie is. Without that, you'll not be able to understand this concept. I'm just going over the concept how to solve this in the linear time using the suffix trie. Will not go over the implementation detail. So please watch my previous video if you don't know what the suffix trie is. Okay. So we are going to create a combined suffix trie for S and R. Now in this suffix trie, right, when you try to find the longest common substring, right? What is the longest common substring between these two strings? One is this string and the other one is the reverse of this, right? Which is this, right? So the longest common substring in both of them will be the palindromic string. They will be the LCS, right? So all the so all the palindromic string substring, sorry, all the palindromic substring in S will be the common substring between the two strings S and R. Okay, so the longest common substring will be ANA, ANA, right? Out of this, the longest common substring is ANA, okay, and that's the longest palindromic substring, right? Now, uh, let's, this is a suffix trie approach. When we have a string, you reverse it, you create a suffix trie out of those two strings, and then you find the longest common substring, which is also a longest palindromic substring. But there is an edge case with this, okay? And the edge case happens when the string S contains the, there's a substring in string S, for example, BBA, and the reverse of this BBA, that is ABB, is also contained in S, okay? So now there's a reverse ABB, which is also contained in S, right? Now here, this string, okay, so this string, this and this is the reverse of this. Both are contained in S. Now when you try to find the reverse of this, it is BBAGF ABB, right? And then between when you create a suffix trie for this to string and then you find the longest common substring, what will be the longest common substring that will be written? BBA and ABB, because those are the two substring which are common between those two, right? But these are not the longest palindromic substring. The longest palindromic substring is BB, not this, not this. And the way to find this, okay, is this. Look at this. So if you look at S, okay, and let's say this is 0, 1. What is a? It goes from index 0 to, so index 0, 1, 2, 3, 4, 5, 6, 7. Okay. So your S is B, B, A, F, G, A, B, B. Okay. And the reverse goes from index. I mean, here you have to take the original index which are there in the S, okay, for the reverse. So reverse will be 2, 1, 0. Okay. So now for the reverse string, okay, for the reverse string it will be B, B, A, G, F, A, B, B. Okay. So now when you find this BBA and BBA as the longest common substring, somehow when you build a suffix trie and when you are traversing it to find the longest common substring, you need to store this forward and reverse index. Okay. So here the forward indexes are 0, 1, 2 and the reverse index for this substring is 7, 6, 5, right? Those two indexes, they are not matching. So this can never form the longest palindromic substring. They has to match in order to find the longest palindromic substring. So now LCS will be equal to longest palindromic substring only when both forward and reverse index matches. Okay, and this is just to cover that edge case when the string contains the substring and it's reverse, right? And it's reverse. Okay, same thing here. ABB, the forward index are 5, 6, 7, and here the reverse index are 2 and 0, which are not matching. So this is not going to form the longest palindromic substring. But in the case of BB, right, this BB is going to match this BB, and both the reverse and forward index are matching. So that's the longest palindromic substring. I mean, that's a palindromic substring. And here also the reverse and the forward index are matching. Okay. Let's take some different example. For example, let me take some big example to show you this. So suppose you have a string. Let's see. I mean, this example is good enough. We can take a longer example, but it's hard to trace. Okay, so this approach gives us a linear time. So the approach that we are going to use is, let's write down the approach. Okay, we are going to construct the suffix trie. Please refer to my previous video how to construct the suffix trie and how to search for a pattern in a suffix trie. So we are going to construct the suffix trie for string and its reverse string. Once we are done constructing the suffix trie, we'll find the longest common substring of S and R, but we will maintain reverse and forward indexes, okay, and that has to match. Now, how to find a common substring in suffix trie? We need to, I mean, the string is the character, right? The character is common if it has both dollar and pound, right? I mean, you will not understand this. You really need to look at the suffix trie video. Okay. But the concept is the longest palindromic substring in S is same as LCS in S and R, but given that LCS in S and R must be from same index position in S. Okay, index position should match. Okay, so this is just the approach I have discussed. We are not going to implement in this video. You can definitely implement it, but it's a very long implementation, and usually you cannot implement in interview setting. So if you're preparing this for the interview, you I mean you can discuss this approach, but it's it's a long approach to implement. I mean, you have to maintain those indexes, construct a suffix trie. I mean, you can discuss the approach. So that's it for this video. Thank you so much for watching.